Hello everyone, welcome to the third MAPME tutorial on YouTube. Today we are going to talk about data sources that you can use for your own GIS projects. My name is Gunnar, I work in the Data Service Center of GIZ and I will guide you through today's training.
Hi, my name is Elena and I also work in the Data Service Center in GIZ.
All right, let's get started. So last training, and if you haven't seen them, you can check the videos on this channel. We showed you how to load datasets in QGIS and how to visualize them, and we used both raster and vector data, right? So as a quick recap, I loaded the data from the last training, and here you can see power lines, power plants, and administrative boundaries for Ethiopia and neighboring countries. And what we also used last time was population density. And here you can see a visualization of the population density. So this is just to recap, you can access this data in the description of the last video if you want to reproduce it. So today we want to see what data sources are out there, because so far you have been provided data and you have worked with the data that has been provided. Today we want to get you going in finding your own data set and integrating your own data in your GIS project. We have a few different data sources we want to touch upon today, and I will quickly switch to my browser window and show you a few data sources. The first one I want to show you is fieldmaps.io. Fieldmaps.io is a data source where you can find administrative boundaries, basically for the whole world. Of course, there are different in level of detail, but in general, field maps is a pretty good data source to get started with your work. And on field maps, there's different data sets available. So if I click on data, you can see there's admin 0, which is basically only the nation states. Then we have also edge matched, where we can also see the lower level administrative boundaries. Today we will work with lower level administrative boundaries, but we will get to that later and then actually show you how to use the data sets. The second data source we want to talk about today is OpenStreetMap. OpenStreetMap is basically the Wikipedia for maps. So here you can see a vast repository of topographical data that is hosted openly, so everybody can access all the data that is included in OpenStreetMap. And as you can see, it's available worldwide, and it also incorporates different local languages. So for example, to stay with our example, if we look at Ethiopia, you can see that it also supports local languages. The same if we zoom in, for example, to the Levante region. OpenStreetMap has this public-facing part, which is the web map, but there's also a Wikipedia or a wiki of OpenStreetMap where you can find more information about the project, about the data and the data structure and how to contribute data yourself, because the interesting part about OpenStreetMap is not only that you can access data and use it yourself, you can also contribute data to OpenStreetMap. The third data source I want to show you is Humanitarian Data Exchange. And Humanitarian Data Exchange is basically the place where you can find a lot of different data sources that are sourced to one place, which is provided by UN OCHA. And there, if you click on data, you will see an extensive data catalog with different topics, different levels of detail for different regions. They also have special data projects for specific countries, but you can also just click at any country here and see then the data sets that are available for this country. HDX from UN OCHA is, as I said, pooling different data sources together and making them more easily accessible. We will not go into detail on how to use this platform now, because we will focus on the actual data sources behind it. And the last one I want to show today is ACLED. ACLED is the Armed Conflict Location and Event Data repository, and there you can find data on conflict events, and they have different dashboards and tools and interactive maps that you can use for your own work. And if you want to work with the data directly, you can also download the data. And I will also show you how to do this in a moment. And ACLED, for example, also has the Ethiopia Peace Observatory where they focus on political violence in Ethiopia. So this was just to mention all the data sources we are working with today. Now, of course, we want to show you how to actually use the data. And first, we'll start with the basics, the boundaries. In the last training, as you remember, you already received a package with national boundaries for the African continent that we used. This time, we want to show you something more, right? We want to give you basically the next level of detail that's available, and you can get that using field maps. So on field maps, if you click on data and you click on edge matched, you have access to subnational boundaries. And there's two different data sets available. One is called humanitarian, one is called open. The open one uses OpenStreetMap and GeoBoundaries, which is a different data source, and the humanitarian uses the United Nations Common Operational Data Sets, where it's available. For now, I wouldn't worry too much about this, to be honest, and I would just download the open one and select the admin level you want. You can get 0 to 4. The higher the number, the higher the detail, basically. And I already downloaded 0 to 3 to show you. The data is available as a geo package, which you know from the last trainings. In case you haven't seen them, you can go back and learn about geo packages. And I already downloaded the data because it's quite big. And here you can see the admin 3 polygons geo package, which is the result of this download here. And if you click on it, if you open the folder, you will see that there's one geo package file. It's about 3 gigabytes large because this contains then subnational boundaries for the whole world, not only a specific region. And if I load them into QGIS, I can just drag and drop them into my GIS. And then you can see that there's millions of polygons basically showing up, demonstrating or outlining different levels of administrative boundaries. Now, if I zoom out for the whole world, it's going to load forever. So I will just zoom into Ethiopia right now. And there you can then see these administrative boundaries, and I will remove the color fill so that we can see the background behind it. And now you can see the admin 3 level of Ethiopia, and you can also query them to figure out what you're looking at. And if we, for example, go to the capital and we query it, you can see admin 1 name, Addis Ababa, admin 2 name, region 14, and admin 3 name, Kirkos. And we are now looking at the red polygon is now Kirkos, admin 3 level. And here we can see the data as admin 3 level. You can, of course, then also filter for admin 2, and then you will only see admin 2 and admin 1. So you can also have a more aggregated view. But that's what you can do with this administrative data. You can basically do then the same processing that you did for the administrative 0 as well. So you can filter this, and you can only display the boundaries that are interesting for you for whatever your purpose is. And now you have access to a global data set. So every time you need administrative boundaries, there you have a starting point. As this is an international global data set, of course, this will never be 100% accurate 100% of the time. So there are regions where these borders might deviate from the actual borders on site, or there might be areas where there's no borders in this data set, but actually there are data boundaries already available. So take it with a grain of salt. You always have to be critical about your data source and consider that this is a global data set and they're trying their best to be as complete as possible. But it's never 100% and you can never blindly rely on this data set, right? But still, I think it's a great starting point. And I personally also use this data set really a lot.
I have a quick question. Why is in some areas the polygons are very big and in some areas they're very small?
This depends a bit on the administrative boundaries per country. So not every country has 3 levels of administrative boundaries. And also the administrative areas are not the same size in every country. This is due to local tradition. This is also due to the environmental conditions. So for example, if we go to Saudi Arabia or we go to the south of Algeria, we have a large desert with very few settlements, and thus the administrative polygons are usually also bigger. And we can also see regional differences. For example, if we go to Europe, let's see until it loads. You can also see that, for example, in Czechia, there's a different edition for administrative boundaries than in Germany, and you can clearly see that there are different sizes.
Wow, it's a big difference, yes.
All right, coming back to Ethiopia now. We already loaded the administrative boundaries, and we already had a look at a few parts of the city, of the capital city of Addis, right? But now, let's say you don't know by heart where Addis actually is, right? It's tough to navigate on this map because you only see polygons, and if you go out further, you will of course recognize the national boundaries, but it's still tough to orient yourself. And to do that, we need a base map. So we need some kind of background map that we can use to see where we are, and also that we need to visualize what we are looking at really, and not only look at the administrative boundaries. And one easy option to get this base map is by using something called WMS. WMS stands for Web Map Service, and this is basically a streaming service for maps. So if you have a WMS provider, you can use this provider, connect to the WMS server, and load data. This sounds very complicated, but actually it isn't. So here I have a small cheat sheet where I have my notes, and here I have the domain or the URL of WMS provider. And copying this, I can now load data into my QGIS. So I click on Open Data Source Manager, and there I have an option that is called WMS, WMTS. Sorry, I had something open still. And then I click on New, create new service connection. And here I can then enter my URL that I just copied. And I will name this ux.at because that's the name of the server. And I will just let everything as it was and click on OK. And if I now click on Connect, it takes a second, and then I can see the datasets that are available on this WMS server. And S2, for example, stands for Sentinel-2. Cloudless means that it's a satellite image without any clouds, so it has been pre-processed already. And I will just take S2 Cloudless 2023 and then click on Apply. And then wait a second. Okay, I did something wrong. Let's check. I have to click on Add, not on Close. Cross. And now we can see that the satellite image is loading. And I will move this image below the admin boundaries so that I can see the boundaries again. Now, black boundaries are not ideal in this case, so I will just switch them to white, but you can color them or you can style them any way you want. Now, this is nice to see and to visualize, especially if you're looking at natural phenomena like deserts or forests or anything in between. But if you want to get really an overview of the area you're looking at, probably you're not looking for a satellite image, probably you're looking for like a regular topographic map. And there we can also use one from this layer, and this is called OSM. And OSM, you might remember that from 5 minutes ago, is OpenStreetMap. So I click on Add, and now I can see a map of Ethiopia. I can also move this below my boundary layer so that I can see the boundaries still. And if I now zoom in, my map will automatically adjust. So it's not static, it's dynamically created. So now it takes a second and then it updates the data based on my actual zoom level. And if I zoom in further, I can even see more detailed roads and can find information about buildings and others. Now you can see the satellite image. OpenStreetMap takes a second to load still. Okay, let's give it some time. While this is loading, you can see it's updating now. I will zoom in further.
How can I also work with the OpenStreetMap data?
Yes, you can also work with it, but not using a WMS. So what we see here is just an image, right? The WMS is only streaming an image to your machine. This image is responsive, right? If you zoom in or out, it changes the level of detail and everything, but you cannot, for example, query things. So last time we queried things, so I have the query tool selected and I click on the airport, for example, but as you can see, I'm clicking right now, but nothing happens. Also, I cannot select things, right? So for example, if I want to select all the buildings, the select icon is not active. So these are things that you cannot do with the WMS. The WMS is basically for viewing purposes, mostly. If you want to actually work with the data, you have to download it. But the good thing about OpenStreetMap is that you can actually download data. So for example, if you are used to working with Google Maps, for example, and you have Google Maps as a background, there's no way for you to access the actual data behind it. But with OpenStreetMap, that's entirely possible. And I can show you a rather easy way to do that. So there's a company called GeoFabrik. You don't have to remember the name, you just have to remember the link. They are a German company and they provide up-to-date data extracts from OpenStreetMap. And if you go to GeoFabrik and you go to the download section, which I have open here now, you can then select your subregion. In this case, we're interested in Ethiopia, so we click on Africa, and then you can select Ethiopia and actually download the data directly. So in this case, you can download the shapefiles. There's also other formats, but I would recommend starting with the shapefiles because it's easiest to handle. And if you click on this, I already prepared this, you will receive this zip file, which I unzipped, and then you have this data set here that's called Ethiopia latest free. And here we can see then the shapefiles downloaded, and you can see there's different topics. There's waterways, for example, there's roads, there's traffic, there's transport, there's railways in case there are some, there's natural information, there's land use, and also, for example, buildings. What we are looking at now is roads. So I click on roads free, and I just drag this into my QGIS. And what we can see now in orange are the roads that are contained. And if you compare this to the background, you can see that it's the same roads. So now, instead of looking at the pre-processed OpenStreetMap, which is basically just a background image, we can also look at the actual data behind it. Now, OpenStreetMap has different styles for different scales. So if I zoom out, I will not see any small back alley in the capital anymore, but it will reduce the scope and you will only see like major roads. But if I now activate my road layer again, it's a mess because it shows all the roads at the same time. And if I'm working on like a very detailed level and I want to see like a certain area of the city in high level of detail, this is excellent news. If you want to see maybe something like the whole country on a larger scale, then it's a bit troublesome because you only see orange basically because there are so many roads. However, there is a way of filtering those. In the first training, I think you already filtered administrative boundaries, and we can also filter these roads here. To do that, it's always good advice to first look at the attribute table. So now if I look at the attribute table for the roads, it's going to take a while to load because it's a lot of files. We can see the different attributes that these roads have, and we can see one of those attributes is called F class. And F class has different values, for example, residential, primary, trunk, secondary, service, etc. Now, this might not immediately ring a bell. So let's find some info about this. So I will switch to the OpenStreetMap wiki, and I've prepared the page for roads. So all road layers have the key highway in OpenStreetMap. If you just type OpenStreetMap roads wiki in Google, you will find this page. And there you can see the different kinds of roads that are mapped in OpenStreetMap. And you can see motorway, trunk, primary, secondary, tertiary, and other types as well. And you might recognize those names because, for example, trunk, primary, we already just saw in the actual attribute table of the dataset. So now if I now query or if I now filter the layer, I can select the roles that I want to see on a large scale, so less detail. So I go to source and I build a query for filter. And there I select F class because this is the name of the attribute. And I will click on F class and I click on values all. Then QGIS will show me all the values that the table has for F class. And I want to see only the major roads. So I will just write a query that only includes the major roads. And if I go back to OpenStreetMap, I can see the major roads, motorway, trunk, and primary. So we can see primary, for example, links larger towns. And that's the level of detail I want for this. So I will only select those three. So we are in the query builder. I have F class, and I want F class to be either primary or secondary or trunk. So I click on them, and if I want to filter for several different values within one attribute, I have to separate them by comma, put them in brackets, and use in as an operator. So now I have F class in, primary, secondary, or trunk, and now it will take all the polygons or all the lines in this case that are either primary or secondary or trunk. If I click on test, I can see that there is roughly 13,000 items. That sounds reasonable. If I click on OK, I can see that I now have a rather nice looking overview of the major roads in Ethiopia. So now that I have these roads, I can, for example, query them. So I will zoom in a bit, look at others again. And if I click on the query tool now, which wasn't available using the background layer earlier, I can then query the roads, and I can see, for example, that this is the road from Addis Ababa to Bahir Dar. I click on this one and can see it's the new road to Ambo. So I can get attribute data from those roads, which was not possible in OpenStreetMap. What I can also do is do geoprocessing. So for example, I can buffer them to identify all areas that are closer to a certain distance to those roads. And I think these roads, as they are the major roads, might be actually good for this kind of analysis. So we could, for example, use them to figure out which of the power plants that we saw in the last exercise are, I don't know, closer than 20 kilometers from the main road network. So I can take these roads and then I can click on vector geoprocessing tools. Just trust me on this. We will not go into detail how to do geoprocessing. I will just give you one example with those roads now. And then there's a tool buffer, and the tool buffer basically marks the area that is in a certain distance from a layer. And I have selected already QGIS GIS OSM roads, that's the layer with the roads, and then I can add a distance. But in the distance, you can see that there's this orange symbol. And for the unit, it says degrees. But we don't want to work with degrees, right? We want to work with the distance in kilometers or meters. So something seems to be wrong with this layer. And the reason is that the layer is not projected to a coordinate system that uses meters. It uses degrees. And you have seen that in the first training already. Currently, we are looking at coordinate reference system that is using degrees, and it's called 4326 WGS84. And we need to calculate this layer again, or recalculate this layer, because it needs to be in a different system that is using meters. So I will export it, and by exporting it, you can change the coordinate reference system. So now I will save this in the same folder where I also have the other roads, and I will just call it Ethiopia roads 3857, which is the coordinate reference system I want. And then here I will change this one to pseudo Mercator, which uses meters instead of degrees. And I will just click on save. It will load for a few seconds, and then it will load the layer again. And now, as you can see, this one has EPSG 3857. And now I can use it to calculate stuff in meters. So I will go to geoprocessing again, to buffer. And now I can give a distance in meters or even kilometers. And I will now say 20. You can enter any value you want. And I will dissolve the results because I want one area in the end and not per road. And I click on run. And then it takes a while to process because it's actually a lot of data it has to process. And now we can see all the areas that are closer than 20 kilometers from one road. I will make it transparent so that we can see the background behind it. And I will give it a color that we can recognize on the map. And now you can see the roads initially, you can see the buffer zones, and you can see the power plants. And you can see that there's basically only one power plant that is more than 20 kilometers away from the main roads. And then we can, for example, also compare this to the population density of Ethiopia. And then you can see that, to no surprise, the absolute majority of people live closer than 20 kilometers to the main road network. These are just examples of what you can do once you loaded the OpenStreetMap data into your GIS project. So if you want to have it for viewing only, you can use the WMS. It's very light, very easy to do, and you have a nice background. You can also do this with other topics, like, for example, sentinel imagery, if you want a satellite image in the background. And if you want to process the data yourself, you will have to download it and add it to QGIS as actual shapefiles or actual vector data. And then you can get, for example, roads and the buffers. All right, now that you have seen what you can do with OpenStreetMap data, just as an example, and you know there's lots of other data sets available within OpenStreetMap. We just looked at roads, but there's also buildings and other things. I want to show you a different data source as well. So if we go back to our browser, you remember that I talked about ACLED, the conflict data sets. And if you look at the ACLED page, you can actually click on data, and then there's a data export tool. And with the data export tool, you can export your own data set and explore these data sets. And I did this already. I already exported the data set. So I just select country Ethiopia, and I selected, I think, the last 5 years, and I downloaded the result. To do this, you have to register. I will not go into the details how to register to ACLED. This is well described on the page, but it takes a moment. So I recommend you take your time, do it in your own time. And once you registered, you can get back to the data export tool. And once you downloaded the data, the result will look like this. It's going to be a CSV file, so comma-separated values. And this is basically the table. This is basically the most simple way to store a table that you can imagine, because it just stores data separated by a comma. That's why it's called comma-separated value. And if you look at this, you can see that there's different words, and there's a comma in between. So every phrase you see here refers to one column in my table. So I can take the CSV file, I will close this again, and I can open it with QGIS. And I just want to quickly show you how to do it. So I will go back to QGIS. I will deactivate the other things we did before that. And then we click on the data source manager again. So here's the data source manager icon. This is also where we loaded the WMS data. This is where you loaded the geo packages in the last session. And this time we want to look at delimited text. There's already a comma next to it, so this should be your hint that this is the one you need. And if you click on delimited text, you can then add the CSV layer. So we have the file name, and there you select your CSV file and click at open. And then you can see the file format. We have already selected comma as the delimiter. This is already pre-configured. In case it isn't, take your time, look at the screen, see what marks are set and what marks are not set, and try to reproduce these settings. I didn't change them manually. QGIS recognized it automatically, but in case it didn't work on your side, you can refer to this screen. And if you go down, you will see that the layer already is being displayed. Now in the Excel you saw it was a total mess. Everything was in one line, but here you can see that it's nicely separated. You have an event ID, you have a date, you have a year, then you have the disorder type, the event type, and these are further disaggregated in sub-event types and actors, for example. So this looks fine to me, and I can continue scrolling to the right, and at some point you will see latitude and longitude. So here you can see the coordinates that refer to the place of the event. And QGIS automatically recognized that longitude refers to the X field and latitude refers to the Y field. So we don't have to investigate further. We can just click on Add and see what happens. So I click at Add, close this window, and now I can see hundreds, if not thousands, of points. And every one of those points refers to one line in the table. So now what we did is we visualized the spatial distribution of those conflict events. Again, if you compare this to the population density, you can of course see that this also somewhat aligns, because in areas with no population, usually there's also no conflict. So now we can see those events, and if we open the attribute table, we can also see the data again that is included in the Excel in the CSV file, and that is curated by ACLED. So now we have a lot of different columns, and we could do all sorts of things. For example, we could, filter for events that are related to civilians or that are related to rebel groups or different other factions. We can also filter by the type of event. For example, is it political violence? Is it demonstrations that turned violent? So it really depends on what your interests are. And you can then filter these and do your analysis based on that. I'm sure some of you are familiar with those data sets already, but for some of you it might also be interesting, and maybe some of you will see it for the first time. Now, this is already giving us a good indication where the conflicts are happening within the country, but there's also a more elegant way to display this, and you can display these events also in the form of a heat map. So if you double click on the layer and you go to symbology, you've learned a few basics on this already in the last session. Instead of single symbol, you can also select heat map. And if you select heat map, you can select a color ramp. I will now do from white to red, just as an example. And then you can select the radius, and the radius basically determines how close events can be until they are summarized into the heat map. And I will just say 5 millimeters. So this says millimeters on your map, of course, not in the real world. And in this case, we have 5 millimeters. And I will just click on apply and see what happens. So now I can see this blurry heat map, and I can see the darker it gets, the more events are happening in this area, in this specific area. And if I increase the distance here, it will become more aggregated and less spatially disaggregated. And if I zoom in again, it will become more disaggregated again, because, as I said, it's using millimeters. and millimeters refers always to your screen. And if you want to weight them, you can also, in theory, weigh them again, because you might think that some events are more intense than others. So, for example, you could weight by fatality and apply, and then it would give a slightly different picture. So this is a very elegant tool to visualize the distribution of points. And as you remember, we only loaded the CSV file and only changed the way it's displayed. And now we went from a table to a heat map that we can actually use to reproduce the distribution or to visualize the distribution of events. So what you have seen here are just a few examples that we thought might be interesting to show to you how you can actually get data in your project. So now you know how to visualize it and how to explore the data sets, and you know a few data sets that you can actually use. So let's have a look at them one by one again. So we have the administrative boundaries, which you can get from field maps. We have OpenStreetMap, which is an open topographic map. It includes all kinds of different data that you can use. Everything you can see here, you can also load and process in your GIS system. Then we have ACLED, where you can get data on conflict events and either explore it on the page or download it and process yourself. Or you can go to Humanitarian Data Exchange, where you can find data sets sorted by country or by intervention area or by topic. These are just a few examples of data sources that you can use. We just wanted to show you the basics on how to import them, how to visualize them. Of course, there's hundreds, if not thousands, of data sources that we did not touch upon. But I hope that these can serve as a first orientation and can maybe inspire you to get started loading data into your QGIS and playing around with them. Thank you for your attention, and see you then in the next workshop.